Okay, well, I'm doing my best to get everything in shot here so we can see what's going on. I was just playing around with this thing the other day. We've got the cap dump circuit all wired up, so our back EMF will go into this cap, and when the relay fires it disconnects the SSG circuit from the cap and connects the cap back to this cap, which is hooked up to our run battery. Standard configuration. This green lead here and the red lead is simply the power for the timer on the cap dump circuit, which we will be running from our charged battery. So as you can see, if I hook it up, and I've got it set for 1 second on and 7 seconds on the charge. So the cap will build up for 7 seconds, and then 1 second it'll dump it over into this cap, which of course is hooked up to our run battery via this meter here. So we'll just start it up. This meter here is reading the voltage in this cap, and this meter here is reading the voltage in the dump cap. So as you can see, our two caps at the moment are of course the same voltage as our run battery. There is what a 0.03 difference between the 2 meters, close enough. So because it's hooked up to the battery, of course they're going to have the battery voltage in them. So what I'm going to do is I'm going to start it up. We're going to run our load like we were in the last video. Be able to watch the cap build up. Now I'm only on 12 volts this time, and this turned down, or should I say the pot is turned up fairly high, so a fairly high resistance, so as it doesn't drain a whole lot of power, it's only just going to keep the motor ticking over. So the back EMF going into the cap won't be that great, but it's certainly enough to make a difference. You will see every time the relay triggers and dumps the voltage back in here, quite often this will go into a negative current, which means it's putting a little bit back into our run battery. So I'll start up with the load on it. Then what I'm going to do is do what I did the other day. I'm going to disconnect our generator from the load and hook the generator back up to the caps. We can watch the amp draw go down, and then I'm going to disconnect the run battery from the cap, and this is the part that I've spent the last 3 days trying to work out what is actually going on. But first we'll start her up. I'll give it a run. You can see our voltage builds up. Well, I hope you can see I'm doing my best to get it in the camera. I'm not going to resize it. I'm going to load it up standard format, so it's going to take a while. But the voltage builds up. I'll let the machine pick up speed first. But you'll see the amp draw goes down every time the cap dump system dumps the charge back into our run cap. And there comes the boy on his motorbike, so it's going to get a bit noisy in here. I did change the bearings in here, and I've used the shaft and head out of a old VCR, and that battle you can hear is just the machine bouncing on the bench. So what I'm going to do now is disconnect our generator coils from the load and hook them back up to the cap, and we should see the amp draw go down. So as we can see, that is our cap dump voltage. You'll see the voltage jump up in our run cap every time it dumps the charge into it. And you'll also see the amp draw go down a bit. So I was assuming that's as good as it would get, so I decided to go up and have a coffee. Morning smoko, chat with the missus. And what I did was disconnect the run battery. Machine started slowing down like it is now, and so I went up to the house. As you can see, the voltage in our run cap's getting lower and lower and lower. So it's a very good indication it's no longer being fed by the batteries. As you can see, the cap dump system is working very well. Dumps it in. Now I haven't got hardly any of the back EMF going to our charge battery anymore. The charge battery is running that relay timer, and most of the back EMF is going back into our cap. So the back EMF that's going back into our charge battery isn't quite enough to keep this running. So we could probably eliminate this system altogether and use a mechanical one with a gearbox. That would solve that problem. So as you can see now, there is nothing hooked to the positive side of the run battery except for the negative side of the charge battery, and we need that just to complete the circuit for the back EMF to go into the battery, because when this relay opens and disconnects from the back EMF of the transistor, it needs somewhere to go so we don't blow the transistor. just grab the at the moment 297 RPMs. So I've been over this many times. This side of the circuit, as you would know, is in no way hooked up to the back side of the relay, which is this side, so it's not getting any power from the charged battery, otherwise this would not be dropping down to that voltage. The only thing that the start of the run coils are hooked up to is our run caps, which are these three. And also now, because we've hooked the generator up to here, these three caps are also incorporated on the run side. So that will keep running like that, on and on and on. It's been running like that 2.5 hours before I done this video. There's absolutely no torque left in the flywheel. Touch it with my finger, it will stop. So we can't do anything with that. And it's pretty much well using everything it's got to run itself. So as for being useful, at the moment it's not. As for it being self-powered, well, that's what I have. What you're seeing is what you get. Like I said, the only thing that's hooked to the start of the run coils are these caps. Nothing more. So that's what I have. I'll cut the video off now so it doesn't take 6 hours to download to YouTube as it normally does. But the voltage in our run cap's a clear indication that we're not using any part of the batteries to run this machine. It does seem to be running itself, but if anyone's got any ideas as to what else might be going on, I'd certainly appreciate them. Okay, cheers from the Tin Man.